Alright, hello everyone. Today I'll be going through the ACJC H2 Math Prelim 2021, Paper 1, questions 1 through 6. There are actually 11 questions in total, so I will record questions 7 to 11 separately, probably tomorrow. But yeah, it's been a really long time since I did one of these videos, and that's because I've been focusing on my own studies as of late, but I decided that I'd finally be able to put some time back to be doing these videos about doing solutions to some papers. I'm going to go through some of the prelim papers that I have. So I'll probably go through for 2021. I have the papers for ACJC, Hwa Chong, Raffles, NJC. I'll probably go through some of those if I can. But right now we're going to go through ACJC 2021, paper 1, questions 1 to 6. Okay, so first question is graphs and transformations. We have this function. F of x is equals to 1 minus e power x divided by e power x minus 2. So show that f of x can be written in the form e to the power of g of x plus a. Alright, so let's see. I can split the fractions. So this will give me 1 over e to the power of x minus 2 minus, alright, e to the power of x divided by e to the power of x minus 2. Now e to the power of x minus 2 is e to the power of x times e to the power minus 2, right? So this is actually, I can also take the reciprocal of this and write this as e to the power of 2 minus x, and then minus, so this is e to the power of x times e to the power of x minus 2, so the e to the power of x cancels out and I'm left with e squared, alright? So therefore my g of x is actually 2 minus x and my a is minus e squared. Okay, that's the first part. Second part, describe a sequence of transformations to transform the graph of y equals e power x onto f of x. Okay, let's see. So we can see that there's a couple of ways you can go about it. I'm going to translate 2 units to the left. So if I translate y equals to e power x 2 units in the negative x direction, which is towards the left, you replace x by x plus 2. Then I will reflect it in the I'll reflect this in the y-axis to change x to negative x. Finally do the translation of negative e squared. So let's write that down. I'll probably write down the parts to the questions also. This is question 1, part 1. And this is question 1, part 2. Okay, so first step I would do is translate 2 units in the negative x direction, or whatever phrasing your school will teach you, followed by the second step is to reflect in the y-axis. Followed by a translation of e squared units. Now this is minus, so this goes in the negative y direction. Of course, there are many possible answers for this. As long as you know what you're doing, you should be able to get a correct answer. Alright? So that's question 1. Okay, question 2. We have the curve C, x cubed minus 2y squared divided by x squared plus 3y, 3xy rather. This is equals to 1, and I'm going to label this question to part 1. Okay. Now, of course, when we do a gradient question, so this is find the gradient, so we know that there's going to be differentiation, and it looks like implicit differentiation. Whenever we do implicit differentiation, we try to avoid using quotient rule. So let's multiply out. so that we get something nicer to work with. We're going to differentiate both sides implicitly. With respect to x, on the left hand side you get 3x squared minus 4y dy dx. On the right hand side you get 2x plus 3x dy dx plus 3y. We'll make dy dx the subject. So if you bring over 4y, you get 3x plus 4y. You bring over the terms on this side also. So you get dy dx equals to 3x squared minus 2x minus 3y divided by 3x plus 4y. Nice. The points P and Q on C each have x coordinate of 1. So if I can get the thing here, we're going to substitute x equals to 1 and we'll find out what happens. So you're going to get 1 minus 2y squared equals to 1 plus 3y. Now this becomes a very simple quadratic equation. The 1's cancel out, so you get 2y squared minus 3 plus 3y equals to 0. And I think you can see y equals to 0 or y equals to negative 3 over 2. We can go ahead and find dy dx for each of these. Okay, let's see. For this one, it should just be 1 over 3. And for negative 3 over 2, you get negative 11 over 6. Okay. Now, what's the acute angle between the tangents to C at points P and Q? So 2 part 2. Alright, what's going to happen here is, let's just do a very quick sketch of the lines with gradients 11 over 6 and negative 11 over 6 and 1 over 3. 11 over 6 is very close to negative 2, so let's do something like that. And 1 over 3 is less than 1, so we'll do something like that. Alright, so the acute angle is going to be this thing, and it's less than 90 degrees. You can see that these two angles are equal. This is tangent inverse of 1/3, and this angle here is tangent inverse 11 over 6. So just add the two of them together, and you'll get the answer. You'll get (79.8 degrees to 1 dp). Oops. Okay, nice. Let's do question 3. We are given f. We're given f of x to be a over 2 minus x. Okay, where x is any real number, which is not 0 and 2. Okay, so we're going to find f2x first. which is just f of x, right? So this is a over 2 minus a over 2 minus x. Alright, we're going to define this function. So let's try and simplify. So this is 2 minus x, so you get 4 minus 2x, so you get a 2 minus x. Minus 2x minus a. And I'll flip the signs over, so I'll get ax minus 2 divided by 2x plus a minus 4. Alright, so I'll leave it like that. And what's the domain of this? Domain of f2. Now, domain of a domain of GF is just the domain of f, right? So it will be the same. Sorry. Okay. Now we're going to find f inverse. Let y equals to f of x. So we have, we're going to make x a subject. So 2 minus x, y equals to a. So a over y is 2 minus x. So x itself is 2 minus a over y. Okay, so f inverse x is 2 minus a over x. Okay, domain of f inverse is the range of f. What's the range of f though? Now, there's a horizontal asymptote of 0 as x tends to infinity, and the vertical asymptote of x equals to 2, right? So actually it can take on every value except 0. So that will be the range of f is just this is going to be the real numbers except for 0 itself. Actually no. There's a bit more to it. Because f inverse cannot be a over 2. Because f of x itself, it's stated that x cannot be 0, and in that case you will get a over 2. So a over 2 is not in the range of f. So therefore f inverse the domain excludes a over 2. Okay. Nice. So I have the two functions. Part 2, we're going to say that f2 of x equals to f inverse of x. So we're going to solve for that particular value of a. Ax minus 2 divided by 2x plus a minus 4 equals to 2 minus a over x. X. Alright. So we're going to multiply out. A times x minus 2 equals to 4x. Actually no, I'm going to cross multiply. So there's no need to cross multiply, I can just multiply both sides by x, I think. Ax x minus 2 over 2x plus a minus 4 equals to 2 minus a, and we do not want any x terms. Oh, there's 2x minus a, sorry. Okay. We're gonna multiply both sides by 2x. Yes. Multiply both sides by the denominator. Ax times x minus 2 equals to 2x minus a. 2x plus a minus 4. Okay, and you'll see that there's actually a x square here and an x square there. So by observation, a equals to 4. And we can try and verify this because if we do that, 4 times negative 2 is negative 8. On the right hand side, we'll have 4 times, this will become nothing. So you just get 2x minus 4 multiplied by 2x itself. So yes, you will get the same thing on both sides if a is equals to 4. Okay, of course you can try and expand it out and show that that will be really the case. Okay, find f2021x. So we have established that f2x as f inverse of x, alright, which implies that f3x is actually the identity function. And any multiple of x is actually going to be x. Alright? Any multiple of 3 will be the identity function. So what number is divisible by 3? F2021x is actually F2019 times F2 of x. Okay? Actually, I think it might be better if I wrote it as F2 times F2019. Okay, so F2019x, 2019 is a multiple of 3, so it's just x, so it will be F2x. And we actually defined F2x earlier, so what is it? It's going to be, when it's 4, the bottom's going to be 0, so it's going to be 2x, 4x minus 8 divided by 2x. Which can be simplified to 2x minus 4 divided by x, and if you wish, 2 minus 4 of x. So that will be your f2x in this case. Okay? Although I think both of these forms will be accepted. Okay, that's question 3. Question 4. So we have a curve C. Y equals to x times x plus a divided by x minus a, which is a rational function. A is positive. So find the set of values that y can take. There's a standard approach for this. We're going to make a quadratic equation. So let's do multiply both sides by x minus a. So I'll get xy minus ay equals to, I'll expand this, x squared plus ax equals to 0. Sorry, no, not yet. We'll form the quadratic equation in terms of x squared. Now we're going to get the x terms together. So this is plus a minus y x, and then plus ay. And this is a quadratic equation. We're going to look at the discriminant of this. Which is b squared minus 4ac. So a minus y squared minus 4ay, which is y squared minus 6ay plus a squared, right? Now what do we want? We want to find the set of values that y can take, meaning that there must be some value of x for which corresponds to that y. So for there to exist x whose image under f is y, we need discriminant to be greater than or equal to 0, right? Because if not, then it won't exist. It won't be a real number. So we need y squared minus 6ay plus a squared greater than or equal to 0. And how do I make this happen? Now notice that I have 6ay here. What if this is a perfect square? That would help me a lot, right? So let's go ahead and add 8a squared to both sides. And this will give me a perfect square. In fact, this is y minus 3a squared being greater than or equals to 8a squared. Alright, I can now take the square root on both sides and I'll get this is greater than or equals to, so either y minus 3a is greater than or equals to 2 root 2a, or y minus 3a is less than or equals to negative 2 root 2a, right? Because a is a positive constant. And of course you can go ahead to solve the equations, the inequalities rather. So y will either be less than or equals to 3 minus 2 root 2 a, or y will be greater than or equals to 3 plus 2 root 2 a. There you go. Yep. Okay. So that will be the set of values that y can take. We're going to sketch the curve. Now, I already plotted this onto my GC earlier on, but it's going to be the case that where there's turning points, because of the fact that we just showed that this is a thing. You know that if there's no turning points, then it will be all real values. And you will notice that this curve actually passed through the origin also. So let's try to sketch the curve. So let's plan a little bit before we do that, because we want to ensure that we center our graph. So the vertical asymptote is x equals to a, right? What about the oblique asymptote? Because we know that rational functions always have an oblique asymptote. So x, how should we go about finding it? Okay, x times x plus a divided by x minus a. This is equals to x times x minus a. Alright, and then plus 2ax, right? X minus a. This is x plus, alright, and then 2a minus 2a squared. Sorry, 2ax minus 2a squared plus a squared, 2a squared, divided by x minus a. Alright, and then get the 2a out, so I'll get x plus 2a plus 2a squared over x plus a. Alright, and x plus 2a, that will be my that should be my oblique asymptote. Okay, so that's cool. So let me just write a remark here. Oblique asymptote. Okay, so let's sketch the graph now. The y-axis is going to be slightly to the left, and I'm going to actually move the x-axis a bit down also, so that it's something like this. Okay, so this is y and this is x. I want my x equals to a to be the center, so I will do it like that. Okay, alright, this shall be the line x equals to a, and with the oblique asymptote, and this oblique asymptote is 2a. So something like this, y equals to x plus 2a. Okay, and we're going to draw the graph. So you will see that on this side it will kind of approach, and there will be a turning point somewhere that's going to be I can use my graphing calculator for this actually. If you use your graphing calculator, oops, the maximum point will actually lie very slightly to the left of the origin, and it will be above the y-axis also. So if you want to be very pedantic about it, make the turning point here and make sure that it goes through the origin, and then bring that curve down. Alright, there's no need to state the coordinates of the turning point, so you do not need to go and find it. But the main thing is this thing needs to converge down here. It's not very easy drawing it with my tablet pen, so I apologize. Just imagine that it approaches the asymptote, because I think we're all aware of how that works. Alright, and it will go back up here, and if possible make it symmetrical-ish, but if not, just make sure that it converges towards the asymptotes. Alright, you get the idea of this. Alright, that's good. This part I will just draw it so that it looks more convergent. Okay, something like that. You get the idea? Okay. And this is y equals to f of x. Okay. This is the origin. And what is the intersection point? This is actually going to be negative a. Okay. So they say coordinates, right? So this is actually negative a and 0. Okay. The scale is kind of not there, as you can see, because I'm not very good at planning stuff. But if you can draw this to scale, it would be good. But they're not very strict about scale in most JCs. So if you want, you can try and extend this a bit to the left and get the shape that way. By adding a suitable graph and labeling clearly, solve this inequality. Okay, I think it's pretty obvious what graph we need to draw here, right? It's y equals to mod 3x, and we all know what that graph looks like. Y equals to mod 3x. Okay, and it passes through the origin. So we need to find the intersection point here. So let x times x plus a divided by x minus a equal to mod 3x. Okay, so of course it can be positive 3x or negative 3x. Now, actually you will see immediately that x equals to 0 is a solution, right? So what if we solve x plus a times x minus a to be equals to 3x, where x is greater than 0. Okay, so you can do this the normal way. X squared plus ax, we're going to bring this over, 3x squared minus 3ax, and then 2x squared minus 4ax equals to 0, x greater than 0, so therefore what is x? You can cancel this out actually because we know x is not 0, so x is equals to 2a. Okay, and then we will refer to this. So this is actually going to be the line, so this is actually going to be 2a. Okay, And clearly you can see that for the curve to be less than the mod graph, it's going to be x is going to be greater than 2a. But you can actually see that the mod graph is also more than this curve if a is if it's between 0 and a itself, and it's also below if it's on this side, mod, and that side. Okay, so by the sketch alone, we can tell that everything is going to be true except for 0 and up to a to 2a. Okay, so that means that x times x plus a divided by x minus a less than mod 3x. The solution is x less than a, or actually no, it should be x less than 0, or 0 less than x less than a, because we exclude 0, or x is greater than 2a. So that will be your solution to this graph. Okay, to question 5, which is differentiation applications. We have a sphere inside a cone. We need to show the identity for r squared. This is probably similar triangles. This is H, this is O, I'm going to draw this is the right angle, and this is A, and this is R. We're going to use similar triangles. The hypotenuse is r squared, the hypotenuse is square root of h squared plus r squared, Pythagoras. This is a right angle, just so we're clear. And this height here is h minus a, right? So by similar triangles, I'll put r on top. R divided by the hypotenuse, h squared plus r squared. This is a similar triangle, so we have a divided by h minus a. Okay, we can square both sides. R squared divided by h squared plus r squared equals to a squared divided by h minus a squared. Actually, it might be better to put the r squared on the bottom. Might be easier to take the reciprocal of this. Let's try it. This will give me h squared over r squared plus 1. H squared minus 2ah plus a squared divided by a squared, which is h squared over a squared minus 2h over a plus 1. Since h is not equals to 0, I can cancel out the h's. So h over r squared equals to h over a squared minus 2 over a, which is h minus 2a over a squared. And then of course you can make r squared the subject from here. R squared, take the reciprocal, multiply by h. So yes, you get a squared h divided by h minus 2a. There may be a slightly shorter method, but I just did what was the most intuitive to me. We're going to find the minimum volume of the cone using this result. And we are given the formula for cone. So of course we're going to use the r squared in terms of h, and we're going to differentiate with respect to h. So for part 2, we let V be the volume of the cone. Oops. Oh my, what's happening? Alright. V equals to pi over 3 r squared h that's been given to us. So we get a squared here, and this is h squared divided by h minus 2a. Because it's r squared times h. dv dh, this is not too troublesome to use the quotient rule, so let's just do that. You will get h minus 2a squared at the bottom, right? So h minus 2a differentiate h squared, you get 2h. So you get 2h squared minus 4a, and then you keep h squared and you differentiate this, you get just 1. So this is actually just minus h squared. Okay? So this is h minus 2a squared. You can go and simplify this if you want. It's just going to be h squared minus 4a. Let dv dh be 0, then you'll get h squared equals to 4a. Clearly h is greater than 0, so h is equals to 2 root of a, right? Actually, I might be... h minus 2a... Oh, I missed something. Sorry. This is h, not 4a. Oh no. My apologies. Okay. 2h squared minus 4ah. Right, this is h squared. H more than 0, so actually I can change this to not equal 0. Because if it's 0, then the volume is 0, right? Then I have h squared minus h squared equals to 4ah. So h squared equals to 4a itself. Okay. Okay, so sorry, no, h is 4a. Okay, so find the volume. This is going to be 16a squared, 4a minus 2a, right? So this is 8a. So 8 pi over 3 times a cubed. Finally, we need to check d2v dh squared to find that it's actually a minimum. So d2v dh squared, which is d dh of the thing that we saw earlier, which is h squared minus 4ah over h minus 2a to the power of 2. Okay. No, actually it's I forgot to put the pi over 3a squared, although it doesn't affect the result. So times pi over 3a squared. Okay, which is pi over 3a squared. Okay, so I keep h minus 2a squared. This is 2h minus 4a minus this 2h minus 4a. No, wait, no, actually h squared minus 4ah, yes. Then differentiate this, you get 2h minus 4a. Okay, divide this by h minus 2a to the 4th power. This can be simplified quite a lot, so pi over 3a squared. This is 2h minus 4a. h minus 2a squared, then minus this thing, so this is h squared minus 4ah. h squared minus 4ah plus 4a squared. Then minus h squared and add the 4ah. So you're just left with the 4a squared. Okay. divide this by h minus 2a to the 4th power. And this can be simplified further. This is 4 pi over 3a to the 4th power. Actually, I'll bring out the 8 because there's a h minus 2a here. Okay. And this is 1 over h minus 2a cubed. When 1 minute, when h is 4a, d2v dh square is, so this is 1 over 8a cubed. So you get pi over 3a itself. Yeah, that should be it. And this is greater than 0, so this implies that this is indeed the minimum value. Alright. Okay, let's go on to the last question for today. The last question will be question 6, which is a Maclaurin's. We are given, let me write down the question. E power y equals to 2 plus sine x. Of course, we want to make y the subject. You can do that. Y equals to ln 2 plus sine x. And we'll need this for later, so let me just write that down there. For the first part, we're probably going to use the equation as is. If I differentiate e power y, I'll get dy dx times of that. Equals to cosine x. I should technically write differentiate both sides with respect to x here. Okay, and then I will differentiate this again. So I'll get, to keep this, I'll get dy dx squared ey plus d2y dx squared ey equals to negative sine x. And this is actually this is actually going to be e power y minus 2 minus e power y. Okay. Then I can divide both sides by e power y. So d2y dx squared plus dy dx squared is going to be, divide both sides by e power y, so 2e negative y minus 1. So that is what they wanted us to show. By further differentiation of this result, find the Maclaurin series. Okay. For this, we're going to need to find the d3y dx cubed. So once again, diff both sides with respect to x, and let's see what we get. We'll get d3y dx cubed plus 2 dy dx d2y dx squared equals to minus 2 dy dx e minus y. Okay, so we can now sub in everything. When x equals to 0, what is y? Y is ln 2 dy dx is when x is 0, ln 2e negative ln 2, so this is, yeah, it's 0 also. So dy dx times, so 2 dy dx is cosine 0 is 1. So dy dx is half, d2y dx square. So this is 2e negative y, which is half, okay, it's 0. So d2y dx square equals to negative quarter. d3y dx cube is okay. So this side half, this minus 1, and this is half, so this is negative half. This is 1, this is negative quarter, so this is quarter. I think so anyway. No, sorry. Because this is negative 1/4 and this is negative half. So this is negative 1/4 as well. Yeah. Okay. So now I can find the Maclaurin series. So y is approximately ln 2 plus x over 2 minus 2 factorial, so x squared over 8 minus 3 factorial, which is 6, so x cubed over 24. And yeah, okay, there you go. That's how to determine x cubed by using standard series from the list of formulae. Alright, so we've already established that y equals to ln of 2 plus sine x. Now there is a standard series for ln 1 plus x and sine x also, but to use it I need to express this as ln 2 plus ln of 1 plus sine x over 2. Right, here's the MF26. Alright, let's see. So because we need to approximate the up to x cube order, so we're only going to need the terms up to x cube ln, that's right. So we need to get sine x over 2 minus sine square x over 8, because it's sine square x over 4 divided by 2 plus sine cube x divided by 24. Okay, this is ln 2. Sorry, this is approximately. Alright, this is approximately ln 2 plus, now I'm going to use sine x. Sine x is approximately x minus x cubed over 6. So this is x over 2 minus x cubed over 12. And the rest of it, we can just take it as x only, because the higher powers will be higher than x cubed. So x squared divided by 8 plus x cubed divided by 24. And then I combine the x cubed terms together. Ln 2 plus x over 2 minus x cubed over 24. No, I'll put the x squared over 8 first. Minus x cubed over 24. Alright, which is what we got on the top. Okay, nice. So that will be it. That's it for this. Now, when I recorded this, I did make a few mistakes in the middle. So I will be cutting this video about a bit. But other time conditions, I should still be able to finish the papers on time, which is good. So it's been a really long time since I did these videos, so I'm not sure whether my way of explaining things has gone rusty over time. So I hope this has been okay. If there's anything that you didn't understand about what I did today, just let me know in the comments. I'll try my best to clarify. And if I have time in the next few days, I'll record the remaining questions for ACJC, Prelim Paper 1, which will be 7 to 11. This looks like this seems to be a APGP, integration, complex numbers, differential equations, and vectors. Yeah. Okay, although this paper, I will basically say that this paper is not too difficult for a prelim, uh, so hopefully it will be manageable for me as well, and I hope for you guys it will be fine now. So I think I think there's not much to worry about when it comes to the A levels. The A level papers, if you've seen the 10-year series, you'll know that actually they're pretty easy compared to these prelim papers. So if you can do these papers, then you're on the right track lah. So find out whether you're doing well the next time when I finish the rest of these questions. Alright, that'll be all, and I'll see you next time.